Hi everyone, in this video, I'm going to talk about deleteFront. So using the previous example, we have this int list with value 7, 4, 1, and 8. And now we want to call deleteFront on this int list. So what would that look like? Note that compared to the insert method, which returns nothing, deleteFront is different in the sense that it does return the value with deleted. So that is why on the left-hand side, we have this assignment here. This assignment is possible. It's because deleteFront returns the value that's stored in the D node that we're going to delete. Cool. So knowing that, first thing we need to do in deleteFront is to extract the value out of the D node that we are about to delete. So in this example, deleteFront, we want to delete this D node that has a value 7. First thing first, we want to extract the value 7, save it in a variable so that we can return it later. Okay, and the second thing we need to do in deleteFront is to point the new front, which is the new front, I refer to it as the front node after we deleted this element 7, the current front. The new front and previous pointer, we need to assign it to null because there's no longer a previous element in front of this element 4 after we call deleteFront. Okay, and then after that, we also need to update the front pointer to point to this new front, which is the element that has value 4. Okay, so this kind of completes the operation for deleteFront. And some students may ask me, what about this next pointer at the old first element we had, old front we have? Why don't we need to assign it to null? Okay, this is some special kind of feature of Java, which is called garbage collection. If there's nothing that points to this object, so if we look at 7, there's no incoming edge that points to incoming pointer that points to this D node with value 7. If there's no pointer pointing to it, it will be garbage collected by the Java program. So it will be automatically garbage collected. So in this case, we don't need to worry about it because there's no pointer pointing to it. It will be discarded once in a while. So in the end, this completes our deleteFront operation. To summarize what we did, first, get the value from delete from D node to be deleted, which I would call it old front. The old front. And second of all, we need to assign the new front, which is, I label it here. Okay, this is the old front, this is the new front. To null. Thirdly, we need to update front pointer. Cool. And now I also present to you another edge case that you should think about when implementing your code, which is what if we are removing the only element of the int list? What I mean by the edge case is that we have this int list and DL points to it. This is a front back pointer. And there's only one D node in this, in this int D list. Okay, for example, 8. Okay, so in this case, does your code run into any errors? Is there any special conditions you should consider? Is there something else you need to do if you're dealing with this case? Is there any pointer you should set to some certain value? So think about that when you're implementing deleteFront. So good luck with implementing the code.